For more than 50 years, these were the last human footprints on the Moon. A silent testament left in the lunar dust in 1972, a final photograph from a generation that dared to touch the sky. For decades, that was the end of the story. Now, we're going back. For the first time since the Apollo era, 4 astronauts are about to embark on a historic 10-day journey to fly around the Moon. This isn't just another mission. It's a turning point. This is Artemis II, the critical first flight that will define the future of space exploration, our path to a sustained presence on the Moon, and our eventual journey to Mars. What happens over these 10 days will echo for the next 50 years. This is the story of a new generation of explorers, a new class of machine, and a mission that carries the weight of history on its shoulders as it reaches for the heavens. A monumental leap. So, what exactly is Artemis II? Well, it's not a lunar landing. You won't see new footprints in the regolith just yet. Think of Artemis II as the ultimate dress rehearsal, a full-scale, high-fidelity test flight with the most valuable payload imaginable, a human crew. It's the first crewed mission designed to travel beyond low Earth orbit since the final Apollo mission over 50 years ago. The main goal is to prove that the 2 cornerstones of the Artemis program, the Orion spacecraft and the Space Launch System rocket, can safely carry astronauts into deep space, keep them alive, and bring them home. For about 10 days, a crew of 4 will ride the Orion capsule on a journey that will take them on a looping path around the far side of the Moon before returning to Earth. This mission is designed to push the spacecraft to its limits, testing its life support, communication, and navigation systems in the harsh environment of deep space. The uncrewed Artemis I mission in 2022 was a spectacular success, proving the fundamental hardware worked. It flew an empty Orion capsule farther than any human-rated spacecraft has ever gone, testing the vehicle's endurance and, most critically, its revolutionary heat shield upon re-entry. But a machine that can protect itself is one thing. A machine that can sustain human life is another entirely. Artemis II adds that vital component. It will feature a fully operational environmental control and life support system, something not required for the first flight. Astronauts will live, work, and sleep in Orion, verifying that it is indeed the deep space vessel NASA has spent decades designing. This mission is the final, major check before the next giant leap, actually landing on the lunar surface with Artemis III. The titans of Artemis to send humans back to the Moon, you need machines of almost unimaginable scale and sophistication. The Artemis program is powered by 2 technological titans, the Space Launch System rocket and the Orion spacecraft. Let's start with the rocket. The Space Launch System, or SLS, is the most powerful rocket ever built. Standing taller than the Statue of Liberty at 322 feet, the Block 1 configuration used for Artemis II is a behemoth designed for one purpose: to hurl massive payloads out of Earth's gravitational grasp. At liftoff, its 2 solid rocket boosters and 4 25 rupees core stage engines will generate a staggering 8.8 million pounds of thrust. That's 15% more power than the legendary Saturn V rocket that took the Apollo astronauts to the Moon. The twin solid rocket boosters are, themselves, the most powerful ever built, providing more than 75% of the vehicle's thrust in the first 2 minutes of flight. The core stage, that enormous orange tank, holds over 730,000 gallons of supercooled liquid hydrogen and liquid oxygen to feed the 4 25 rupees engines. These are the same model of engine that powered the Space Shuttle, but they've been upgraded and pushed to generate even more thrust. No other rocket in existence can send the Orion spacecraft, with its crew, on a direct path to the Moon in a single launch. Once the SLS has done its job, the star of the show becomes the Orion spacecraft. This is our next-generation vehicle for deep space exploration, and it's made of 3 main parts. At the very top is the Launch Abort System, a powerful rocket designed to pull the crew capsule to safety if anything goes catastrophically wrong during launch. Below that is the Crew Module, the pressurized home where the 4 astronauts will live and work. This is the only part of the spacecraft that returns to Earth. It's built to withstand the brutal conditions of deep space and the even more brutal physics of re-entry, where it will slam into Earth's atmosphere at speeds approaching 25,000 miles per hour. But the real engine of the spacecraft, the part that gives it power and propulsion, is the European Service Module, or ESM. Provided by the European Space Agency, the ESM is a cylindrical powerhouse covered in solar arrays. It provides everything the crew needs to live: electricity from its solar panels, propulsion from its main engine, and breathable air and water from its life support systems. It is the service module that will perform the critical burns to fine-tune Orion's trajectory and, most importantly, provide the final push to bring the crew home. The Trailblazer's machine, no matter how powerful, is just a machine. It's the crew that gives a mission its heart and purpose. The 4 astronauts selected for Artemis II are a blend of veteran spaceflyers and seasoned experts, each bringing a unique set of skills to this historic flight. More than that, they represent a profound shift in who we send to explore the cosmos. Leading the mission is Commander Reed Wiseman. A former US Navy fighter pilot and test pilot, Wiseman has the steady hand required to lead a mission this complex. He's a veteran of spaceflight, having spent 165 days aboard the International Space Station and served as the chief of the astronaut office. His deep experience makes him the ideal leader for this trailblazing journey. At his side is pilot Victor Glover. Glover is also a decorated naval aviator and was the pilot for SpaceX's Crew 1 mission to the ISS. He spent 168 days in space and conducted 4 spacewalks, giving him invaluable hands-on experience. With Artemis II, Victor Glover will make history as the first person of color to fly on a lunar mission, a powerful symbol of progress. The first of 2 mission specialists is Christina Koch, an engineer and scientist who holds the record for the longest single spaceflight by a woman. She spent an incredible 328 days on the International Space Station, conducting research and participating in the first ever all-female spacewalk. Her background as a research scientist in remote locations like the South Pole has uniquely prepared her for a deep space mission. On this flight, Christina Koch will become the first woman to travel to the Moon. Rounding out the crew is mission specialist Jeremy Hansen of the Canadian Space Agency. A former fighter pilot in the Royal Canadian Air Force, Hansen is a highly accomplished astronaut who has been a cornerstone of NASA's training programs for years. While this will be his first flight into space, his leadership on the ground has made him an indispensable part of the program. His inclusion marks another historic first. Jeremy Hansen will be the first non-American to fly to the Moon. His presence underscores the international collaboration that defines the Artemis missions, a global effort to push the boundaries of human exploration. This crew isn't just flying for one nation, they're flying for all. The journey 10 days to the Moon and back, the Artemis II mission, is a meticulously choreographed 10-day ballet of rocketry, orbital mechanics, and human skill. It all starts with the raw power of the Space Launch System. From Launch Complex 39B at the Kennedy Space Center, the rocket will climb into the sky, shedding its solid rocket boosters after 2 minutes and its core stage just after 8. The upper stage will then fire, placing Orion into an initial, low Earth orbit. But unlike the Apollo missions that headed straight for the Moon, Artemis II takes a more cautious, deliberate approach. The crew will spend their first 24 hours in a high Earth orbit, putting Orion through its paces. This phase is critical. They will test the manual controls and navigation systems, which is essential practice for future missions that will need to dock with other spacecraft. Once all systems get a go, it's time for the big push. The European Service Module will fire its main engine in a maneuver called the Trans-Lunar Injection burn. This powerful thrust will accelerate Orion out of Earth's orbit and onto a path across the 250,000-mile void. The journey to the Moon will take about 4 days. The flight path itself is a work of art known as a hybrid free return trajectory. This elegant route uses the Moon's gravity to bend Orion's path and sling it back towards Earth without needing a major engine burn to get home. It's an incredible safety feature. Even if the main engine were to fail after leaving Earth orbit, gravity itself would ensure the crew returns. As they approach their destination, the crew will sweep around the far side of the Moon, traveling thousands of miles beyond it and reaching a point farther from Earth than any human has ever been. They will witness a perspective of the lunar surface unseen by human eyes for over 50 years. After the lunar flyby, the 4-day return journey begins. As they approach Earth, the crew will brace for the most perilous phase of any deep space mission, re-entry. The service module will be jettisoned, leaving the crew module to face the inferno alone. Hitting the atmosphere at nearly 25,000 miles per hour, the capsule's heat shield must withstand temperatures of almost 5,000 degrees Fahrenheit. After surviving this trial by fire, a series of parachutes will deploy, slowing the capsule for a gentle splashdown in the Pacific Ocean, where a US Navy recovery ship will be waiting to bring our explorers home. The "why now" more than just footprints returning to the Moon after half a century makes you wonder, why now? The answer is in the name. Artemis, in Greek mythology, was the twin sister of Apollo. This new program isn't about repeating the past, it's about building on its legacy to create a permanent, sustainable future for humanity in space. Artemis II is the essential bridge between the Apollo era and this new vision. The success of Artemis I proved the vehicle's spaceworthiness. Artemis II will prove it's ready for people, a final exam before NASA commits to landing humans on the Moon again with Artemis III. The entire Artemis program is designed to be a marathon, not a sprint. The goal is to establish a long-term human presence on and around the Moon. This is where the bigger picture comes into play. Future missions will see Orion docking with the Lunar Gateway, a small space station that will be placed in orbit around the Moon. This outpost will serve as a staging point for missions to the surface, a science lab, and a command center. The skills being tested on Artemis II are the foundational techniques needed to build and operate this gateway. In the coming years, NASA and its commercial partners will develop the human landing systems that will finally ferry astronauts from lunar orbit down to the surface. And the ambition doesn't stop at the Moon. The Artemis program, in its entirety, is a dress rehearsal for humanity's next giant leap, sending astronauts to Mars. The Moon provides a relatively close and accessible proving ground to test the technologies and strategies we'll need for a multi-year mission to the Red Planet. Learning to live and work on another world is a critical step that must be taken before we can confidently set a course for Mars. So when you watch Artemis II, you're not just watching a lunar flyby. You're watching the first concrete step in a plan to make humanity a multi-planetary species. The razor's edge, the challenges of today. The path to the launch pad is never smooth, and the journey of Artemis II has been a testament to the immense challenges of pushing the boundaries of exploration. Getting to this point has not been without its hurdles, and the final stretch has been particularly demanding. Following the successful uncrewed Artemis I flight, engineers discovered that Orion's heat shield didn't perform exactly as expected during re-entry. In some areas, the protective material, called avcoat, broke away in chunks rather than wearing away smoothly. While analysis showed the crew would have been safe, NASA delayed Artemis II to fully investigate the issue, because when human lives are at stake, good enough isn't good enough. More recently, the mission has faced other technical gremlins. After successfully completing a critical fueling test, or wet dress rehearsal, in mid-February 2026, engineers detected an issue with the flow of helium to the rocket's upper stage. Pressurized helium is essential for the rocket's operation, and the issue couldn't be fixed at the launch pad. As a result, NASA made the tough call to roll the entire 322-foot-tall rocket stack back to the vehicle assembly building for repairs. This rollback automatically took the March 2026 launch window off the table. NASA is now targeting no earlier than April 1, 2026, for the launch of Artemis II. These delays are a stark reminder that in human spaceflight, you don't launch when you're scheduled. You launch when you're ready. Artemis II is more than a mission. It's a statement of intent. It is a declaration that the dream of exploration is alive and well, passed from the generation of Apollo to the generation of Artemis. For over 50 years, we have been a species confined to our home planet's immediate neighborhood. This flight shatters that boundary once again. The 4 astronauts aboard Orion aren't just testing a spacecraft. They are carrying the ambitions of an entire planet on their shoulders, reigniting a journey that was paused for far too long. This 10-day flight is the first step. It is the mission that makes all future missions possible. It is our historic return to the moon, and our first stride towards a future among the stars.